Today we're going to solve quadratic equations by factoring and using the square root method. So let's first take a look at how to solve by factoring. First, we need to make sure our equation is set equal to 0. Next, we need to factor it. So in this case, we're going to multiply to get 8 and add to get 6. So those two factors would be 4 and 2. So we get x plus 4 and x plus 2. We're going to set each factor equal to 0 and then solve. So our two solutions are -4 and -2. Of course, we can always check our answers by substituting them back into the equation. So if we have x squared minus 2x minus 8. Again, we want two numbers we can multiply to get -8 and add to get -2. So that is going to factor to x minus 4 times x plus 2. We're going to set that equal to 0. Next, we're going to set each factor equal to 0. And then we'll solve. So x is going to be equal to 4 or -2. So if you feel comfortable enough, you can solve the problem to our right on your own. So press pause, try the problem, and press play again when you feel comfortable. So the first thing we're going to do is set the equation equal to 0. So x squared plus 7x minus 8 is now equal to 0. Next, we're going to factor. So we want to multiply to get -8 and add to get +7. So that's going to give us x plus 8 times x minus 1. Still equal to 0. Next, we're going to set each factor equal to 0. So x plus 8 is equal to 0, and x minus 1 will be equal to 0, so that our solutions will be -8 and +1. Again, we can always check our answers by substituting them into the original equation. Now, here are two more practice problems. Press pause, try the two additional problems, and then press play when you're ready to continue. First and foremost, let's set the equation equal to 0. So x squared minus 11x. By adding 5, we're going to get plus 24 equals 0. Now, we will factor the two numbers. Multiply to get 24 and add to get -11. So x minus 8, x minus 3. We'll set both factors equal to 0. So x minus 8 is equal to 0. X minus 3 is equal to 0. So that we get x is equal to 8 and 3. So for this problem, number 2, we have to multiply 2 times 3 to get -6. So my two factors that I want to multiply to get -6 and add to get -1 are going to be -3 and +2. So we're going to expand. 2x squared plus 2x minus 3x minus 3 equals 0. We shall chop in half and factor out a GCF 2x, which will leave us with x plus 1. Here, we'll factor out a GCF of -3. So we'll also have a common factor of x plus 1. So now we'll have 2x minus 3 times x plus 1 again, setting each factor equal to 0. 2x minus 3 equals 0. X plus 1 equals 0. So our solutions will be x is equal to positive 3 halves or negative 1. So now, for additional practice, in your textbooks, refer to pages 229 in your problems 19, 20, 25, and 28 through 34. Now, let's look at using the square root method. To solve by using the square root method, we must first understand how to simplify radicals. Listed are your first 15 perfect squares and their square roots. When you recognize these numbers, it can make simplifying the square roots easier. For example, if we take the square root of 12, if we recognize the largest perfect square that is a factor of 12, we can simplify it easily. So if we know that the square root of 4 is 2, then we can go ahead and know that we can pull the 2, so that this becomes 2 with the 3 left under the radical. Or, if you look at your pairs, after doing the prime factorization, in this case 2 times 2, you're going to pull out any and all pairs so that we still get 2 square root of 3. So in this example, we have the square root of 40. Again, the largest perfect square being 4, and the square root of 4 is 2. And we're left with the square root of 10. If we did the factorization, you see we have a pair of 2's that we pull, and we're left with 2 times 5, which is 10. Now let's try to simplify a couple together. So if we have the square root of 24, if we write down our factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. We notice that 4 is a perfect square. So again, the square root of 4 times the square root of 6 gives us 2 square root of 6. However, if we look at this square root of 50, we write the factorization of 50 out. Some people do trees, some people just write them all out. So 50, you notice 2 times 25, which is 2 times 5 times 5. So here's a pair of 5s that we'll pull out. We have 2 left, so it's 5 square root of 2. So press pause. Using either method, simplify the square root of 48. And press play when you're ready to continue. So here, you notice the largest perfect square that goes into 48 ends up being 16. So 16 times 3. The square root of 16 is 4, so we have 4 square root of 3. Or if you did the factorization, you'll notice we have 2 pairs of 2's, but 2 times 2 gives us 4, and we're still left with 4 square root of 3. Now let's take a look at what happens if we have a negative square root. And the only thing that you're going to do differently is pull your I out. Okay, so if you notice, the square root of negative 4 is simply 2i. Again, because of the negative under the radical, you just pull an I out. So if we have the square root of 9, that will just become 3i. So we're simply pulling an I out. If we have the square root of negative 72, so that's the square root of 36 times 2. So 36 being a perfect square because of the negative, you pull an I out. Square root of 36 is 6, and we're left with 6i square root of 2. Okay? So anytime you have a negative under the radical, just remember, you're going to pull your I out. Now let's solve using the square root method. So your steps, in terms of solving, you're always going to want to isolate the squared term, whether it's x squared or it's the quantity squared. And when you take the square root of both sides, it's important that you remember to do plus or minus. So there will be two solutions still. So if I have x squared minus 36 equals 0, we're going to add 36 to both sides to get x squared equal to 36. Take the square root of both sides, so x is equal to plus or minus 6. Because negative 6 squared is 36, and positive 6 squared is 36. So if I'm solving x minus 4, x squared minus 4 is equal to 0. We want to isolate the square, so x squared is equal to 4. Square root both sides. So x is going to be equal to plus or minus 2. Here, we need to divide by 2 to get the x squared plus 4 is now equal to 5. We want to isolate the square, so we'll subtract 4 to get x squared is equal to 1. Again, taking the square root of both sides, so the square root of 1 is 1, so it's x is equal to plus or minus 1. Now, if that did not simplify perfectly, we would just simply simplify the radicals. So let's try a couple of problems together. So x squared plus 27 equals 0. So the first thing we're going to do is subtract the 27. So x squared is now equal to negative 27. So we're still going to take the square root of both sides. So the square root of x squared is going to equal to the square root of negative 27. So because we have the negative under the radical, we can pull the x out and it's equal to plus or minus. This is 3 times 3 times 3. So we have a pair of 3's. So we can pull a 3 out, pull an I out, and we're left with the square root of 3. So our solution again is x is equal to plus or minus 3i square root of 3. In the next problem, the first step here is going to be to divide by 3 on both sides. Again, I want to isolate my squared value. So we get x plus 5 squared is equal to 7. Next, we take the square root of both sides. So we're going to pull whatever is within the square root sign out. We'll pull the x plus 5, and that's equal to plus or minus square root of 7, because that cannot be simplified. Our last step is to simply subtract 5 from both sides. So my answer is going to be x is equal to negative 5 plus or minus the square root of 7. Okay, so here are 2 additional practice problems. Press pause, do the practice problems, and press play when you are ready to continue. Okay, here are your solutions to these 2 practice problems. Notice here on the second one that once you have your 2 separate equations, you will have to write them separately because it's plus and minus. Okay? So for additional practice problems, you can refer to page 237 and do the problems listed below.